Hi there. Welcome to episode 7 of For Crying Out Cloud. This will be the last one that I tape for this school year, but it's my favorite weather phenomenon of all, and it's tornadoes. So, first of all, a few facts. Tornadoes occur just about everywhere in the world. Antarctica is a place where they do not occur. The U.S. has the greatest amount of tornadoes in the world. We average over 1,200 per year. That's more than anywhere else on Earth. They can form any time of year, but mostly they occur in the spring and summer months in the Northern Hemisphere. Most tornadoes last only 5 to 10 minutes, but some have been known to last more than an hour. And most, but not all, tornadoes in the Northern Hemisphere spin counterclockwise. So what causes them? Well, tornadoes can form out of all different kinds of storms. You need to have a thunderstorm first. But most likely, you need to have something called a supercell. And a supercell has a special area of rotation inside of it called a mesocyclone. And that mesocyclone is what spawns the tornado. So the winds line themselves up just right, and with enough strength, it makes the storm actually turn like one of those toy tops. The air circulation in the storm with the updraft is what makes that tornado form. So if you remember back to cumulonimbus clouds, thunder clouds, you'll remember that we have updrafts and downdrafts. And those updrafts and downdrafts are going to start rotating really rapidly inside of a supercell. So this would be what a supercell looks like in its formation. You can see that the air has risen and now you've got this overshooting top. You've now created a supercell, and this is a special kind of thunderstorm. Now, under the rain-free base of that supercell, as it's being created, you're going to get this thing called a wall cloud. That's before the rain and the hail happen. You're going to get the wall cloud, and right here, this is where the tornado drops from. So here's the updraft as it spins upward inside of the supercell. And that mesocyclone inside, as it spins, can eventually spin strongly enough that it drops down to the ground. So you can see here, this is where you have the wind from the overshooting top. The 5-mile-an-hour wind is down here, but you can see the spinning going on here. The spinning will eventually turn into a funnel. That funnel can reach itself from the bottom of the cloud down to the ground, and that's when a tornado is formed. So this is what a supercell looks like on Doppler radar. You can see it's pretty impressive. And this would be the center of the storm. Here's the back end. This is what's called a hook echo or a bow echo, and the tornado would be located right back here because the wall clouds are right through here. Now, for us in Michigan, when we get hit with a tornado, we usually don't get hit with supercells. We get hit with lines of severe thunderstorms that end up having rotation inside of them. And as they come along towards us, they can drop a funnel cloud, which can turn into a tornado. So, when a tornado is not a tornado, well, first of all, it's only called a tornado if it touches the ground. If there's rotation visible from the bottom of the storm cloud, but it hasn't touched the ground, it's called a funnel cloud. So it doesn't necessarily get called a tornado till it actually makes contact with the earth. Funnel clouds are what weather spotters look for when they're scouting for tornadoes. So when I get called up to be spotting, that's what I'm looking for. And finally, downdrafts and microbursts are not tornadoes. In a severe thunderstorm, you can get those downdrafts and microbursts that we looked at before that look like this, of a downdraft that comes racing down out of the cloud. That can cause the same kind of damage as a tornado, but it is not a tornado. It looks like this when it comes down out of the cloud. It's a straight line wind. That is not a tornado. Now, this is what a funnel cloud would look like. If you look here, you can see the funnels coming down off the wall cloud, right here and right here. And those funnels are what could eventually touch the ground. Now, this is what a tornado is going to look like. Now, this is a very pretty one. You can see it's touching the ground. It's picking this up. Whatever it picks up, it actually turns that color. But most of them look like this. They rotate like this, and they're extremely dangerous at night because you can't see them. The clouds are so dark, and nighttime is dark, so you don't see them coming. Now, we've talked about supercell tornadoes. There's also these little things called gustnadoes. Sometimes they're just little mini twisters that can drop out of the clouds. They last maybe a minute and then they're gone. And then the other thing that can happen are these things called waterspouts and landspouts. And waterspouts actually form over the ocean or big lakes. They've been seen all over Lake Michigan when there's a storm that crosses from over in Wisconsin, crossing across to Michigan. And they're seen a lot after hurricanes coming across the ocean. So this is what a waterspout looks like, and it's an actual tornado that touches down on the surface of the body of water, and it picks up water inside of it as it's spinning. And here's another version of it. Now, Tornado Alley. Tornado Alley is a term that's used to describe specific areas of the U.S. where most tornadoes occur. So the states that are usually there are Texas, Oklahoma, Kansas, Iowa, South Dakota, Illinois, Missouri, Nebraska, Colorado, North Dakota, and Minnesota. Those are the ones part of Tornado Alley. But Texas, Oklahoma, Kansas, and Nebraska get the most of all of those states in Tornado Alley. And that's because continental polar air from the north clashes with maritime tropical air from the south and creates those severe storms that spawn tornadoes. So we'll go back to our air mass map, where we have continental polar air masses that come up from or come down from the north. And then, so they're continental, they're dry, they're polar, so they're cold. Down here you have maritime, which means of the ocean or sea, so it's moist. Tropical means it's hot. And the bigger the difference between this air mass and this air mass is what can spawn those supercell thunderstorms. And that's why they happen in this area right here called Tornado Alley. And you can see the warm, moist air comes up here. You've got cold, dry air, and you've got warm, dry air. This is the continental tropical, and that can just make a whole spawning session for these big, severe thunderstorms. There's another alley, and it actually has the state with the most tornadoes in all of the United States, Arkansas, and this is called Dixie Alley. A lot of tornadoes are spawned from here because hurricanes come in through the Gulf of Mexico, and they get tornadoes that break off of those hurricanes once they make landfall. There are two more alleys that have been named besides Tornado Alley and Dixie Alley. You have Carolina Alley, and that's where North Carolina and South Carolina are. And again, that's where hurricanes make landfall in the Atlantic, and so you get tornadoes dropping off of the hurricanes once they make landfall. And then you have Hoosier Alley. And Hoosier Alley includes things like Illinois and Indiana and Ohio and southern Michigan. And yes, we do get tornadoes. Now, we've done scientists you've maybe never heard of during the school year. Here's another one. His name is Ted Fujita. And Tetsuya Ted Fujita came to the U.S. from Japan in the 1950s. He wanted to study tornadoes. And he introduced the concept of tornado families. Before, people thought tornadoes were one and done. But he found out that there's more than one tornado in a storm, and each has its own unique path inside of one thunderstorm. Prior to this, all the scientists thought there was like one big, huge tornado that did all the damage. So this is Ted Fujita. This is in his lab that he created at the University of Chicago. And if you've ever been to a science museum and you have seen these machines that create tornadoes for you to play in, you can thank Dr. Fujita for that, because he created the very first one in his lab so that he could recreate the conditions and learn more about how tornadoes move and what kind of damage they cause. So here's another picture of him in his lab. He would make small scale models, and he would actually simulate the damage that would happen to communities from these different kinds of tornadoes. So what he did was he took aerial photos. He went up in a small Cessna airplane and he took all kinds of photos and made all kinds of sketches, and he used those to explain tornado structure. There was no such thing as Doppler radar back then. So he had to use all of his observations as a scientist to figure out how tornadoes worked. So he was the one who came up with the concepts of how a thunderstorm is built, what the architecture is. And he introduced the terms like wall cloud and bow echo. And this is one of the diagrams that he actually sketched long before there was ever any kind of Doppler radar. He drew this as to what he believed was going on inside the tornadoes. Now that we have Doppler radar, we can prove that that actually does happen inside of a tornado. So this is a picture of Dr. Fujita in his lab with all of his many sketches and photographs and drawings and maps that he created over, the 50 years that he was doing all of this research. He also created something called the Fujita scale. And in 1971, he introduces it, and he makes the ratings on this scale based on the damage that was caused by the tornado. So there's a scale 0 to 5 that he comes up with, and then he goes out, he looks at what the damage is, and then he can figure out what kind of tornado it was. So in 1974, there was what was called the super outbreak of tornadoes. Until 2011, that was the number one outbreak of tornadoes in 24 hours. There were 148 of them, and it was the most violent tornado outbreak ever recorded because there was 30 F4 and F5 tornadoes, which are the worst there are. So you can see from this map that it went through Alabama, Georgia, Tennessee, North Carolina, parts of Virginia and West Virginia, Kentucky, Indiana, Illinois, Ohio, and even southern Michigan. And down here you've got the Fujita scale. These red ones, those are 5s. Those are the worst there are on the scale. So Dr. Fujita still taught meteorology classes at the University of Chicago, well into his older age, trying to bring a new group of meteorologists into the fold. Sadly, he passed away in 1978, but his legacy clearly lives on because we still use his scale. So in 2007, the Fujita scale was amped up a little bit. It became the enhanced Fujita scale, or the EF scale. What they did was take his damage scale, but they added wind speeds to it because now they could actually calculate wind speeds digitally, and most places in the United States had some kind of device to capture wind speeds. So this is what it looks like. So in EF0, you can see how many miles an hour the wind has to be blowing and what kind of damage. And it goes all the way up to an EF1, 2, 3, 4, and 5. 5 is absolutely devastating damage, the most incredible, and the wind has to be spinning 200 miles an hour or more. So you can see in this picture, this kind of shows you what the damage is going to look like. You can see the difference in the damage between an EF0 and an EF5. EF4s and 5s are going to pretty much relocate your house and every one of your belongings. So let me show you some pictures. This is what an EF0 tornado would look like. This was one that happened in Nebraska. You can see fences knocked down, things blown all over the place, but nothing more than like a regular windstorm. This is an EF1. This occurred in Ohio. You can see part of the roof has been torn off, but sturdy structures like brick structures are still standing. Now, in 2010, there was an EF2 that dropped down in Dundee, Michigan. You may be familiar with Dundee because that's where the water park and Cabela's is. And it fell down pretty much right on top of them. It destroyed, this is part of the water park that it destroyed back in 2010. So this is another picture in North Carolina. You can see it uproots trees, which can cause quite a bit of damage. This is an EF3. Now we're going to start seeing a whole lot of damages with entire roofs taken off. And I want you to take note of what these upper floors look like for when I get to the part about tornado safety. This is an EF3 in Missouri. Again, you can see top floor is devastated. Not a whole lot left. That is not someplace you wanted to be. This is an EF4 in Texas. When you start getting into 4s and 5s, there is massive destruction and loss of life. So it can pick up cars, it strips trees down to the bone. And again, here's another EF4 in Kansas. It has torn out full warehouses and completely destroyed them. Now this is what an EF5 looks like. This is in Moore, Oklahoma. And you can actually see the whole damage path that the EF5 took as it went straight across. So, and you can see some of these houses, it didn't touch them. Over here, this has more damage, but you can see everything that was in the actual path of the EF5 was destroyed. And here's a closer up view of that neighborhood. Again, you can see absolute incredible damage, and fires and things like that happen because gas lines get broken. So, watches and warnings. For this one, tornadoes are possible. You know what? That's what a watch means. But be very careful about this. Do not get a false sense of security. Watches are very large. They can cover a lot of counties. They can cover a lot of states. And a warning means they've sighted the tornado. So either a trained spotter or weather radar has seen the rotation. And it's a very small area because that's what a tornado covers. When you hear that tornado warning, you have less than a minute to get to shelter. So you should have already planned what your shelter was going to be because you don't have much time. So, tornado safety. First of all, go to a basement, the absolute lowest level in your house. As you saw from those pictures, it drops down from the cloud, so it takes the top levels first. If you don't have a basement, go to an inside room without windows on the lowest floor. So you would be down at the bottom level, and you would be fairly safe for an EF0 to 3 tornado, which is typical of what we would get in Michigan. Get under a sturdy piece of furniture because things are going to fall down on top of you. And a table can stop that from happening. The other good thing is to lay in a bathtub with a mattress over you. Bathtubs are attached to pipes that go down really deep in the earth. The bathtub's not going anywhere. And the mattress will keep things like glass and sharp pieces of wood and everything that's blowing at 150 miles an hour from impaling you. They'll get stuck in the mattress instead. If you live in a mobile home or a trailer, don't stay in there during a tornado. They are not anchored deeply enough. They are picked up very easily and blown around and completely destroyed. Get out of your car. You have to get out of your car. As you can see from the pictures I showed you, it can pick up a car. And don't try to outrun the tornado. They are moving at 200 miles an hour. Your car is not going to be able to do that and follow the road, because a tornado will not follow the road. It will follow its own path. If you're outside, go to a ditch or a low-lying area and lay flat. Tornadoes follow straight lines across the ground and won't dip into the ditch. Since they come down from a cloud, they're not going to reach deeper. You also need to be in that ditch to protect yourself from flying debris that's moving fast enough to impale you. And then finally, stay away from all the fallen power lines, because you can get electrocuted, and stay out of damaged areas afterwards, because the structures, the houses and the buildings are extremely unstable and could collapse at any moment underneath you. So let me just give you an example of what a tornado can do. This is a piece of a fence post that has been impaled through a concrete block. This is why you need to not be out in the tornado, because you are squishier than a concrete block and that would go straight through you. So here are some questions to think about. Which country has the most tornadoes per year? How many tornadoes touch down in the U.S. in a year? Which seasons are most likely to have tornadoes in the Northern Hemisphere? What direction do tornadoes spin in the Northern Hemisphere? About how long do most tornadoes last? Which types of storms spawn tornadoes? Which part of the cloud is the tornado located? True or false, continental, polar, and maritime tropical air masses can create tornadoes in Tornado Alley. What's the difference between a funnel cloud and a tornado? What states are in Tornado Alley and how many alleys are there? How did Ted Fujita study tornadoes? What's the name of the scale named for Dr. Fujita? True or false, you should take shelter in the highest place in your house during a tornado? Should you take shelter in a mobile home? Besides a tornado, what other kind of severe weather makes being in a car very unsafe? And if you're in an open area outdoors during a tornado, why is a ditch relatively safe? All of these questions appear on a Google Forms document for you to quiz yourself with and see how you did. I will attach it in the Google Classroom for you. Just a little pun. What's a tornado's favorite game? It's Twister. And speaking of Twister, if you get a chance this summer and happen to catch that movie on TV, please watch it. You'll notice there is a whole lot of stuff that we studied in these videos in that movie. It is my #1 favorite movie of all time, and I'm very disappointed that we didn't get to watch it together and discuss it. So, finally, I wish that you will be safe, stay healthy, and I do send you a lot of love. I hope you have a great summer and good luck in high school. Bye-bye.